Algebra 2. Let's jump into it, guys. We are in section 3, chapter 2, and we are doing some graphing today. All right, graphing linear functions. Everybody be on page 105. All right, so make sure you are always tracking with me in the textbook, because that is going to be kind of the one thing that you got to have there with you when you take these notes, because I'm going to consistently go back and forth between the textbook and the example problems that are from the textbook. All right, so let's jump into it. For those of you guys that do have that graphing calculator, the TI-83, TI-84, then this could be a great section just to give it some practice, because the graphing in itself is not hard enough, that you really have to have a graphing calculator. But if you do have it, this will be real easy to just kind of play around with the graphing function and putting it in the y equals and typing it all out and just getting used to that. Okay, and then kind of maybe do it without the calculator and just see that everything matches up. All right, so there you go. Next thing is the key terms. There are 5 of them. Always look these up, because again, they're going to be used on the test, in the homework, by me in the videos, and you have to know their definitions, because that's not something I'm going to be answering for you come test time. All right, so I need you guys to read example 1. The reason why is I just want to make sure that you understand this whole idea about a linear data set. So it's like they're just going to give you a list of x values, a list of f of x values. So you can think of that as your y values if you're putting this on a coordinate plane and graphing them. And for something to be considered linear when given a data set, then all of the rates of change have to be equal. Okay, and then what am I talking about when I say a rate of change? I'm talking about this guy right here. Okay, so that would be the change in f of x, otherwise known as the difference between every f of x value. Okay, that needs to be the same. Then you need to put that over the change in every x value, again, otherwise known as the difference between every x value. The difference has to be the same. If you're looking at a problem and you have a data set and the either f of x or x differences are not the same, which you will see an example of that, then that would not fit in the category as a linear data set. Okay, so let's keep progressing here. Some real easy stuff that I know you guys have been doing since at least Algebra 1, maybe even 6th grade, is slope-intercept. Okay, so that's the whole y equals mx plus b. So the quick review, m, that's your slope. What is the slope? It's the rise over the run. What is the b value? That's your y-intercept. And then when you are graphing, you always start with the y-intercept, then from the y-intercept, use the slope. And that little sentence there, I just decided to use b and m there. So you got start with b, go from there, work to m. Okay, all right. A couple last notes here. When you're finding intercepts, you would start by making one of the values 0. So let's say you make x 0, then that means you're going to solve for y, and whatever y is, that's your y-intercept. Then go back to the original equation, make y 0, solve for x, that's going to be your x-intercept. Okay, again, you're going to see an example of this. And then the last little note there, anytime you just have something that says y equals a number, that's going to make a horizontal line. And anytime you see something that says x equals a number, that is a vertical line. All right, let's do some example problems. So here we go. We are going to jump into 1A, which is on page 105. So the first thing we do is figure out what is the difference between every x value, okay? And it's looking like the difference here, I believe it's going to be 7 every single time. How do we know that? You have 11 minus 4, that's 7. 18 minus 11, that's 7. 25 minus 18, that's 7. So we have right here, 7 is the difference every time, and it's going up, so we know it's a positive 7 every single time. Then let's take a look at the f of x value, and we have a negative 15. Okay, we're going to subtract a negative 6 from that, and that's going to give us a negative 9. and then we double check negative 24 minus negative 15. That should be the exact same thing. That's going to give us a difference every time of negative 9. And then if we go back, we take a look right here. You want to see the change in f of x over the change in x. So let's write this out. The change in f of x was a negative 9 every single time, and the change in x was 7 every single time. So that means all of these, every single one of them, will have the exact same ratio, negative 9 over 7 every single time. Okay? So we would say, yes, this is a linear data set. Okay? Let's take a look at 1b. So it looks like x's are dropping 2 every time. So that's going to be a decrease of 2 every single time. But now take a look at the f of x values. They drop by 2, but then they don't drop by 2 the next time. Then they drop by 4. So right there, just within from here to here, it's a drop by 2. But then from here to here, it's a drop of 4. So that's not the same. If it's not consistent every single time, immediately we know this is a no. This is not a linear data set. Okay? All right. Now some simple graphing here, guys. They give you slope, 4 over 3. They give you a point that the graph passes through, 3, 1. So all you're looking at needing to do here is first plot that point that they give you, 3, 1. So go to the right 3, go up 1. Looks like we are right about there. Then from that point, use your slope. Remember, this is rise, this is run. So from that point, we're going to rise 4. 1, 2, 3, 4. We're going to run 3. 1, 2, 3. Looks like we would be right about there. Okay? From these 2 dots, you can just create a simple line to go right there. And that's it. So that's the exact graph that I would need to see for any problem where they give you a slope, they give you a point, plot the point, from the point, use the slope. Okay. Let's jump into example 3, find the intercepts. So this is where we're going to start by making x 0, plug in 0. So what happens? You have 6 times 0. That would cross out, leaving you with just negative 2y equals negative 24. Then divide both sides by negative 2 to isolate the variable. So y is going to equal a positive 12. That means that is my y-intercept. Now go back into it, and then we're going to make y 0. And let's go ahead and say negative 2 times 0 would be 0, so that would drop out, leaving you with just 6x equals a negative 24. Then again, we got to isolate the variable, divide both sides by 6, and the x-intercept is going to now be a negative 4. All right, perfect for that. So again, remember, make x 0, and that will cross out the x along with the coefficient with x, because anything times 0 is 0, leaving you with just the y variable, and there should be a constant on the other side. Solve for y. Do the same thing, and then you'll get the x-intercept. All right, let's do these last 2 here. They're going to be pretty quick. All right, good. So we have, simply on this one, slope-intercept. Remember it, y equals mx plus b. Isolate y. That's the most important thing. Get y by itself, which seems like all I have to do is switch these guys. I got to get negative y, which is great. Move it to the other side. It's going to become a positive. Negative y crosses the equal sign. It's a positive. Take the positive 9 and move it to the left. That's going to make it a negative 9. and the 2x never moved. So it's right there. This is it. This is your y equals mx plus b format. So that one right there is done. Now, a little bit more movement with 4b here. The y, notice this y is a positive. I don't want to move it, okay? So what I do want to do is take that 30 and move it to the other side. So I'm isolating y one step at a time. So what I have here now is 5x. We moved the 30 over. It crossed the equal sign, making it a negative 30 equals 15y. Then I got to get rid of that 15, so I isolate the y completely by itself. The only way to do that is to divide everything, all the terms, by 15. So we do that, crosses out here, 15, 15. All right, we're going to need a little bit more space. Maybe we're going to work above it. Okay, so 5 over 15, that's going to reduce to a 1/3 x. Negative 30 over 15, that's going to reduce to a negative 2. And now y is by itself. So right there, that's our y equals mx plus b format. Perfect. And now we have the easy stuff. Okay, look back at the top of the notes. Right here. Y equals a number, it's a horizontal line. X equals a number, it's a vertical line. Now we go back and all we have to do is say which is which. Y equals a number. What is that going to create? That's going to create a horizontal line. X equals a number. That's going to create a vertical line. Okay, so again, all I did, let's look back at the notes. Right here, x equals a number, vertical, y equals a number, horizontal. Now here is what is actually happening if you wanted the full graph picture. Okay, real quick here. All right, we'll use another color. If you had y equals 5, you would simply have a line that goes like that. Notice a horizontal line. Okay. Also, I just realized that I never finished the L right there. Okay. And the next part. If you had x equals just a half, it would probably be right about here. Again, creating now a perfect vertical line. Okay. That's all I got for you guys. All right, that's the notes for section 3, graphing. And again, rewatch them, do everything you need to do to make sure you understand it. Try out those graphing calculators if you got them. I'll see you guys in the next one.